The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
Your kid was pawning you both out of getting bananas?
Apparently in milk, because there's now 3 gallons of milk also downstairs. So she apparently texted both of us, and both of us, yeah. Now there's
Both of you fell for it about I need milk and nanners.
I don't know what the hell is going to happen with all these bananas.
What are you rubbing on the desk? Stop it! Stop it! Jesus!
Right. God damn.
You're unbelievable. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. How's your week going? I'm home for once. I was traveling abroad to everywhere, and now I'm home for 1 week, and then I got to go to another really humid place. I was in Florida for 1 week, and now I have to go to Louisiana. So I'm wondering if the next place, never mind. I got to go to Houston anyway.
Florida's disgusting right now.
Sorry, I had to answer the door. I didn't know if it was a little kid or something, because the kids go in and out of my house all the time, and I don't know. One kid rings the bell perpetually, and usually I'll mess with them. I'll open up the door. I'm like, "Who are you?" And they're like, "I'm Cole. I've been here before." And I just slam the door in their face. And like at first they would look at me like, "What the fuck?" And now it's just a running joke. And then they'll just, after I slam the door, they'll open up the door and just walk in.
Jesus Christ.
That kind of neighborhood. Yeah. So traveling, I'm actually at home going to really humid places for the next 2 weeks after. So I'm going to Louisiana and then going to Houston. Great. And it'll be old equipment, so my hands will actually be dirty.
Oh my God. You're actually going to have to work on old stuff, and you're going to get dirty, and love it. I'm just thinking like chaos, startup hell, everything's on fire, like
It's just a split system, Kevin.
Yeah,
what could possibly go wrong with the split system?
Single units, and then we're changing condensers the next 2 days, so it's going to be just a trip.
You're changing condensers in the middle of summer?
Yeah.
Because that makes sense.
When they're halfway water cooled, it does. You got to keep supply rolling across the border.
You do what I did up in Connecticut. We had the store we would work for. They would just upsize the compressor and then just add capacity, upsize the compressor, add capacity.
Oh, we're doing the same thing.
But did nothing for the condenser. So
yeah.
Then they got pissy because they're like, "We're using a lot of water." I'm like, "Yeah, because we need it. Total heat rejection is way over what it needs to." And so like at one point they were just like, we'd have to go back to the store and shut off the water. So I got really pissed. So we came up with this awesome plan. I got to give it to Scott Hilke if you ever listen. He created this bucket, and the bucket had a water solenoid, a thermostat, and just an electric plug that was watertight. And basically what it would do is we attach the sensor onto the drop leg. So if the drop leg ever got up past about 100 degrees.
That's some real hacky shit.
But hey, listen, we didn't have to go there and back every single time.
You know what? And if you didn't fix it, they would be forced to buy new condensers. Did you really do anybody a favor?
Listen, they were aware of the situation. They knew what they had to do. It's not my fault that it's not in the CapEx for this year. Not my fault.
It's going to be in the CapEx whether they want it or don't want it.
Yeah, agreed. So tell me about besides fighting with single systems and changing out condensers, what else is going on?
Oh, nothing. It's just like tons of programming or stuff needs set up and programmed, and just it's like everything's colliding at once. I'm running around like a chick with my head cut off, and
Per usual.
yeah, so it's just exhausting.
But the way you're working on those XJs, right?
Yeah, so those XJ units, they're nice, but the problem is they have quite small receivers in them for their size.
Where's the expansion valve? Or not the expansion valve. Where's the solenoid?
At the case. What? Yeah, I'm not a big fan of cases on single units that don't use suction stops. I despise liquid line solenoids on any cases that are on a single unit. I think it's they have such ass control with liquid line solenoids.
You realize every week that list just keeps getting bigger, right?
Yeah, but it's with liquid line solenoids, you have so much overshoot on a case than you do a walk-in cooler or freezer coil. It's so much overshoot that it becomes difficult to deal with and troubleshoot and control the case and deal with defrosting issues. I think a suction stop solenoid provides such a better control and even a better defrost when the coil's flooded.
Are they still using those? What are those controllers in there that they were using? XCM 25 or something like that?
Yeah, XCM D25 or 25D. Yes. So like that's an awesome controller. There's so much flexibility with that thing. What it could do, they could do digital compressors. It could do like ramping. It could do all kinds of stuff. It's variable speed fans. It's great. It's a great controller for a condensing unit. Like honestly, it's a little. Your options on programming, it's a little limited, but other than that, I think it's great. Like that is a great thing. Like I think it's better just ripping it out of the extra unit and put it in other units too. You take that from that unit and use it on a heatcraft unit. Like it's a great monitoring controller.
Yeah, so if no one's familiar with what he's talking about, this is what he is talking about. You have the XCD25 here, this controller. You can program everything through here, but are you using WizMate or the web UI to get into it?
WizMate usually.
Okay. So WizMate's a program that you need in order to talk to a lot of these different Dixell products, where it'll give you like everything. Where if you were to com this into a E3 or an E2, you might not see all the parameters, but with utilizing WizMate, you could basically see everything, every single parameter on this.
Now, you don't need WizMate to program this thing. You could program from scratch. It's not that bad. It's not like super intensive where like you can't do it. Like you can program this from scratch. Mm-hmm. You're going to need an RS-485 to USB adapter to get into this, to do the programming.
Hold on, RS-45 to
USB.
Okay. Oh, like the ones used on, I'm going to date myself, but the ones used for like control and shit.
I think so. Yeah, that one will work because it's RS-45.
Yeah, and then the one used for the core sense modules as well.
Correct. Yep. So it's the same one for the core sense modules. It's like $10, $15 on Amazon. Correct. So you could use that for any of the Dixell products to get into for the most part.
Yeah.
If you need to update a program or whatever, you could do that. There's supposed to be a hot stick in there. But generally on startup, these are pretty simple. Like you got to cut in, cut out. It's a glorified pressure control. So you got to cut in, cut out. And it's also doing the vapor injection. If you have economized vapor injection scrolls, because a lot of these X-Line units, the low temp, have vapor injected scrolls in them, like a rack would. So they have a subcooler in them. So they're able to provide subcooling in there so they don't need to have liquid injection for low temp. So you're not losing BTUs on liquid injection. You're just gaining efficiency by lowering the liquid temp. You can see Brett's got on there. You got the fan set up. Not the biggest fan of the way the condenser fans are set up. Like it's a pain to work on for that side of it, but they do really good. They're quiet and they're variable speed out the box. So it uses a PWM fan to modulate the fan motor. So it's using a chopper. I think it's a PWM chopper output.
Don't get me the line. I don't.
Yeah. I know. It's set up weird, but it's using a PWM signal to modulate the fan motors. So you could have one or two motors modulating. There's no holdbacks on these or what do you call it? A receiver pressurization valve or hold headmaster. Not the biggest fan of it not having a headmaster, especially like up north. It's bad. But as long as they got the wind guards, supposedly they're supposed to be fine.
Oh, because of the head pressure drop and the capacity change and all that other crap. Yeah.
Yeah.
But a place like Chicago. Oh, by the way, we're talking about this today. We didn't even say. We just rolled right into it. But we're talking about these condensing units and the trials and tribulations that you might need to look for. But yes, windy places like Chicago, obviously, but also
Texas.
I told you before.
It's windy.
Dude, when it's 10 degrees in Texas, feels different than 10 degrees in Chicago because there's
you're
nothing.
Just soft now. You're soft. If you came from Connecticut, you would have said that.
Oh no, my blood has thinned. My blood is thinned. That first summer, I think I have a picture of me on the floor of a rack house, just dying because I didn't realize like how much liquid I have to consume, and I was like, oh, I'll just drink a lot of Gatorade now. Blah, nope, now it's not go down.
Yeah, so a couple things to consider were like when you're putting cases on single units. Okay, where's the liquid line solenoid going to be, or suction stop? What type of setup are going to be? Don't try to do multiple cases on one condensing unit and with multiple different controls. It's not going to work. Do not put EPRs on single units.
The only thing I was going to say XCM 25 can also do the actual defrost control for us for the actual stuff downstairs.
Now you got to watch because in those units, it's depending on what is powering it. So if it has a contactor or a relay, most of them, the relay is too small to carry more than a small coil. But you have to have an auxiliary. You're cycling an auxiliary switch or relay or something like that, or a contactor.
Gotcha. So you're not doing any high. Yes, because it's probably, I don't know what the limit is. I know actually I have one here. I don't want to go hunting for it, but I don't know if there's any relays or I'm sorry.
So inside the X line, I don't think there is, but inside the actual X line, there is a separate space for a defrost contactor at times. So when you are using a larger load, you may need a defrost contactor. Yeah. Oh, but like what I said, like when you're designing a case, single cases or multiple display cases on a condensing unit, try not to put EPRs in and stuff like that. And then some consideration needs to be looked at during the pump down. How many pounds of gas is going to come back and pump down? So like today I had 6 medium temp cases with 6 different liquid line solenoids on one unit. So the pump down capacity of all the cases together was like 18 pounds of gas, not including this whatever gas is in the suction line that had to be pumped down too. So it was probably another half a pound. So you figure I was close to 20 pounds. The receiver is 9 pounds at 90%.
And that's the thing people fail to remember because they're like, oh, wait, the pump down device, whether it be an electronic expansion valve, whether it be a liquid line solenoid, is right next to the case. But they need to remember, like, you have a dual state of refrigerant in that coil. It's not just vapor. It's a very heavy mix of liquid. So you have to take the liquid capacity of the coil into consideration when you're doing this. That's why having something like suction stop or electronic EPR would help in a situation like this. So yes, you can still shut it down, but you want it to be positive shutting. So basically you're only pulling the vapor out of the ass end of the coil, out of the suction line going up. So with a small receiver like that, you don't overburden the receiver that's actually in there, in turn causing maybe like high pressure pump down problems.
Correct. Yeah, that's where you get into with this, because you also got to remember if it's a case in your liquid line solenoid, you have one and you get 60 feet of case, that is a lot of pipe inside the case that has to pump out. And here's the other part of this. While you're pumping that out, the case that's closest to the liquid feed is going to dramatically shoot down in temp, while the case that's on the end of the liquid feed is going to start starving and is going to start warming up. So you're going to get this like unbalanced temp thing. So you may be balanced while they're running, but then when it shuts off and stops running, they're going to go like this. The case closest to the liquid feed is going to get colder, and the case warmer is going to get warmer. So you're going to get this temp imbalance that looks all over the place. That's why a suction stop is instant, almost. So like you're going to instantly stop flow and start to warm up.
Or if the unit is sized properly, what would be badass with this, where you never really shut down, doing a mechanical EPR on the ass end of the suction and have as much run time as humanly possible, where the only time that it actually shuts down is during defrost. Now, you were dealing with medium temp systems today, yeah?
Yeah.
So having an EPR on there, because this will load and unload that compressor. Does yours have digital unloading on yours?
Nope. Just standard compressor, which you're hosed at that point.
Stupid. And why would you do that?
Because you can't. You have no unloading. You have nothing.
I know, but why? You bought this awesome X-Line thing that has all these capabilities. I know there's only certain model numbers that have the freaking unloading, but why? Why wouldn't you do it? Why wouldn't you use it?
Because it's more expensive.
It matter.
But my thing is another thing. If you're going to do cases on single units, whether it's an X-Line or whether it's any other unit, buy the hot gas bypass and the liquid injection, because it buys you more runtime. So you get more runtime on there, so you could keep this thing running faster or in better. Just keep going. I'll keep talking.
Okay.
So the hot gas and liquid injection allows you to set the evaporator pressure minimum. So Target does this all the time on single cases, or if they do an add-on and they put some cases on a single condensing unit, they take and they use hot gas injection with a hot gas injection valve, and they use liquid injection. The liquid injection to then cool that gas back off, because you're dumping hot gas in the suction. So now we need to de-superheat it, and we dump liquid back in there to flash off and cool down the compressor, so that way we don't overheat the compressor. Now, when we're doing this, we could set the minimum load. So say the minimum we need is a 20-degree evaporator. So we're setting it right at a 20-degree evaporator, maybe a degree higher, 21 degrees. So that way you keep that unit running as much as possible. The goal here is to try to keep the cycling down, because when you start cycling on discharge air temp in a single unit application, you're going to be all over the place. You're going to have poor performance. You're going to have product shrink. You're going to have temps all over the place, icing issues as you get too cold. Oh, sorry. You're gonna have all kinds of issues like that. So that's why suction stops and taking in liquid and hot gas injection, if you're going to do this, are amazing things. Getting VFDs on here and digital compressors, that's a lot of money at that point. Now you're making a huge investment into something that maybe should have been a mini rack. But on to the next thing is sizing receivers. So when I'm like looking at a job and I'm looking at the layout, okay, you got the piping schematic, you should be able to look at your liquid piping and say, I have 200 feet of 5/8. I got 150 feet of 1 5/8. You should be able to calculate your liquid capacity on the line and your suction gas capacity, and then look at your cases. If you have 5, 12-foot Husman multi-deck cases, they're going to say, okay, it's 18 pounds for the cases. It'll tell you how much pound per foot or how many pounds per case. So it'll give you that whole setup, and what you're going to do is you're going to calculate out your charge.
Today's episode is sponsored by the RefruShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
So say with your field piping and your case and your evaporators in your case, okay, I hold 22 pounds. If the condensing unit you have only has a 9-pound receiver, that is not going to work. If you put a suction stop in there, it'll work and get you by, but actually sizing the lines out and everything else so you have the capacity to pump down this unit so you don't hit when it's 90 degrees outside, you aren't stacking gas and filling the receiver 100% when 1 or 2 units shut off or you're in defrost and then you're popping off on high pressure control.
So I'm looking up the information for the is it
XJ? I think they're XJSs or XJs. I don't remember
because I'm trying to bring that up because the receiver is itty bitty.
They have a chart in there, so it shows what the receiver capacity is. But obviously, the receiver capacity is bound by the size of the unit. So if you have a super small unit, you're going to have less capacity on the receiver. So you may have to.
Those aren't microchannel either, now, are they?
No, they're not.
Yeah. All right, never mind.
So it's one thing you need to keep into account. It doesn't happen all the time, but I've been seeing undersized receivers a lot lately. We just got one on a CO2 rack not too long ago that you can't pump the store down. So it is something that's important when they're engineering this stuff and to double check it, because when you go to start this thing up, you're in for a surprise.
XJ24 or something. I thought I had something on the whole damn unit, but the only thing I had...
They literally list the capacities on the receiver versus what like the actual gas is. So if it's like 448, it may hold 9 pounds. If it's 404, it may hold 9.3 pounds.
Yeah, they have a whole document. Just rifling through it real quick. I thought I had this, but yeah. So there is a part number for the hood. Yeah, it looks. Is this one a double stack or a single stack?
I had a single
just
and I
one.
had a double for low temp.
Okay, so let me just show this real quick because maybe I've just never noticed when I worked on these before because that was a thing at one point. You have a power board. Do you have this, or is it just XCM 25 in there?
XCM 25.
Okay, so that's not a thing then. So manual defrost. So this must be an optional controller where it doesn't have all the bells and whistles. Once again, if you put that damn controller, the XCM 25 in there, wow, fuck, wouldn't you do some sort of digital unloading? You know what I mean?
I was surprised on the medium temp that they were running liquid injection, which is cool because it keeps compressors from overheating, but they had a EEV stepper motor there running liquid injection.
And it's a unipolar motor, right? It's
yes.
It's the one that they usually put on the core sense modules, that 5-lead one, right?
Yep.
5 or 6 lead. So here's your pump down capacity. So I don't know which unit you had, brother. You know which one?
I don't remember.
Okay. So you see they got 7.5 and 11 pound capacity as far as
not that much gas.
No, dude. If you got 4 huge ass cases, I don't know how to figure that out. Vine and I, Bob, we were having a conversation about this because we were working on a system where we were having perpetual ice ups. And the reason why is because they use so many more fins per inch. It was like for the cooler, it was like 8 fins per inch, and for the freezer, it was like 6. Where usually you do 6 for the cooler and like 4 for the freezers. And we were just having the conversation like, why wouldn't you just, if you remove more fins, yes, you'll have less surface area. And then basically your coil would have to get bigger. That's why. Because remember, like I was working on some monoblock stuff. And if the coils, you're only allowed to have 150 grams, the charge was already 148. So if you added a bigger coil because you took out less of the fins, basically now you make that coil bigger. And like I stated before, you have a split phase of liquid and suction gas in there. So that's something you got to take in consideration when you're doing this pump down. It isn't just what's in the liquid line, it's what's in the coil as well.
Correct. That's why I think a suction stop makes a lot more sense, or just cycling off the contactor.
What cases were on there? Were they Hills?
They were Hussmann, like ID5 SU, like whatever the fucking
ID5 SL.
Yeah, they were glass or medium temp, so they're not much. And the other thing I want to bring up, guys, is when you're doing singles or you're doing coils and you're doing electric defrost, make sure that you have some sort of pressure limiting power head, or you have some way to control the pressure coming back post defrost.
These have electronic valves down there?
No, they're TXVs.
I didn't know if they, okay. You have to look because there's only certain power heads have for medium temp and low temp have a certain pressure limiting. So especially if you're doing low temp, I know off the top of my head, I know that the low temp power head for 404 and 507, they have a pressure limiting power head that will not allow the superheat to feed normally until the pressure gets down to 40 pounds. I don't know what it is, the pressure limiting on the low temp, but like on the medium temp, that might be a little bit bitch because I know that there's like one for a commercial charge. It's something P100, which means that the pressure is over 100 pounds, then it'll start to limit. You know what I mean? But you got to see what the pressure is going to run. You were running what, Kevin? 448, 449, something in there?
448, yep.
So let's just say, for argument's sake, that would be 18 degrees saturated. You're probably trying to maintain 43 pounds, right? Midpoint.
33 degrees saturated is what it was sized for.
Oh, so not
that the medium temp really didn't need pressure limiting, but the low temp definitely did.
Yeah. Pressure limiting power heads are comparable to a crankcase pressure regulator. The only difference is a crankcase pressure regulator you can adjust for an exact pressure, where the pressure limiting power head, you're limited on whatever the number is stamped on there. You can't change that. So
generally, you don't need it on medium temp because you don't have that much pressure coming back. Like if you are defrosting, or like a temp control, say it gets up to 40 degrees, it's not going to be a tremendous amount of load coming back to the compressor. But you imagine when you just take a ton of liquid and inject it into a 60-degree coil for low temp, you have all the load in the world now, and that's going to overload the compressor.
So check this out. So I brought up your case. It's not the Dord case, but I just brought up the regular standard medium temp because Jamie's not that quick. But estimated charge, and you had how many footers?
See, these ones were a little bit more, but I had 5 12-footers and one 8-footer.
Holy shit. So 2.9 times 5, and depending on which unit you had, 2.9 plus whatever's in the liquid line prior. So 2.9, I can't fucking math today. Dude, my brain is just broken today. I can make funny memes about people, but I can't. See, 2.9 times 5 equals, that's 14 and a half pounds. So even if you had the bigger receiver in the unit you were working on, that pump down capacity was freaking 11, and that's not accounting like where you only had one solenoid, so you were shutting all the liquid off for everything, so you had to count for also whatever was left in the liquid line. You also said this unit had a subcooler, correct?
This unit didn't, the low temp did.
Okay, take that in consideration, right? Because we all know when we run the subcooler, the refrigerant gets more dense. It fills up more surface area within the pipe. So this number really, maybe not so much on the coil wise, but as far as in the liquid line, that might increase a little bit.
The other thing I realized I don't think, because I looked at this, they don't designate whether they're top fed cases or bottom fed cases in that charge chart. So if they're top fed, which these were, that's another like 10, 12 feet of line on every single one of them.
All right. So unit number, it says number 12, note number 12. This is an average for all refrigerant types. Actual refrigerant charge may vary by approximately half pound. So we could have a half a pound more per case than what we did. So 1, 2, 3, that's an additional 2.5 pounds on top of the 14.5 that we just roughly figured out. Right.
Yep. So you're way over. You're never going to be able to pump that down for service.
Hell no. So having some sort of suction stop, that would be amazing. Shit, a suction stop / EPR, because then at least you're
I would stray away from the EPR because that may lead to issues with the compressor.
Yeah, that's right, because there's no capacity control on the pump. Remember?
Yeah,
if you had a capacity control and some guy that sizes this with 2 letters behind his name does it properly, right? They should be sized for the area that they're in. But with a lot of the systems that we've dealt with, that's why you said, which I agree with Kevin, hot gas bypass and desuperheating is the way to go if you don't have any capacity control. Go ahead and keep talking. I'm going to bring something up real quick.
Yeah, the target units run great.
So at one point did not have it in there, and they were saying that we go through a lot of compressors, we have a lot of ice ups, and I had a meeting with them. I was like, they're way oversized. You're running way low of a saturation than what it is. So we had a meeting and decided it was like, we have 2 options. You could do 2 compressors, which is silly because if you lose one compressor, I'm searching the wrong thing while I'm talking. But you can do 2 compressors, but if you lose one compressor, then now you have to change the other one out versus doing the other. What the hell was I just going to look at? I totally lost train of thought. Oh, no, never mind.
Yeah, the hot gas and liquid injection is a stable way to do this. It does work, but properly sizing your condensing units works better with not oversizing units. And all the single units I see are so oversized, it's ridiculous.
But hey, it's going to work in the 2 days out of the hottest day of the year, and that's all that matters.
Yeah, and then all winter long, it's just absolutely horrendous suction control.
Yeah, it's going to eat shit there the rest of the. If you're not aware, blah, blah, blah. Hot gas bypass valve basically it's big with pharmaceutical because a lot of those can only vary within like tenths of a degree as far as what they're allotted to. So there are 2 methods of doing hot gas bypass valves. So I'm going to show you both. Charge. No, not that one. And they're not showing you the one that I want to show you. So you can do 2 ways of hot gas bypass. You could run a hot gas line all the way down to the expansion valve, but if you do that and feed it into an auxiliary side port, that way the expansion valve is then big enough to open up, and then you don't need the liquid injection. We're all on this charge mitigation type thing where we don't want to use more charge than what we have to. So now the preferred method is basically up at the condensing unit. You would have both of these have to be on a solenoid, so be mindful of that. You have to have a hot gas solenoid for the hot gas bypass valve and also for the liquid injection or desuperheating valve. Because here's the thing, if we're injecting hot gas into the ass end of the compressor, that compressor is not going to make it that long. That temperature can be 140, 160, 180 degrees. We all know that we need 20 degrees of superheat. We also know that typically most medium temp Copeland compressors, including air conditioning compressors, do not want greater than 65 degrees. So if we do that, we'll start breaking down oil and all kinds of other happy stuff. So what we do is we set this hot gas bypass valve typically for the midpoint of whatever saturated that we're trying to maintain. So in Kevin's instance, we're trying to maintain 33. I think those cases usually have a 6 degree TD or something like that, or is it 4 on those ones, Kev?
That particular case was 4.
All right, so 33 degrees saturated would give you essentially a 37 degree, or I guess 38 degree set point. So you could set the controller for 37 and then maintain essentially 38, what the prime of the case needs to be. Now, as we're injecting hot gas, we're going to end up taking out that compressor. So the purpose of the desuperheating valve is basically to negate the actual physical temperature, the sensible heat that we're now injecting in the ass end. Now you can see the bulb of that is usually placed on I think it's the outlet. I think the outlet of the accumulator. Typically, if it does have one, otherwise it's on the suction line just entering the compressor, and you set that accordingly. Now there are rules with this, just like there is with any kind of hot gas liquid injection, like the 1037. Like you have to size it per the horsepower and the suction returning and all that other happy horse stuff. So there are rules with that. The power head that you're going to see on the top of there is an L1. So it could be, I've seen G valves used as liquid injection and SBQ valves used for liquid injection, but the only difference is the notation, instead of being commercial or low temp, it will have an L1, means liquid injection. There are other ones. There's an L2 and an L3, and I'll bring them up in a second to talk about it. But anything else you want to add?
Yeah,
to that
here's the thing. Liquid injection and hot gas injection is great, but you can't completely rob Peter to pay Paul. So
you're losing the efficiency that you would have gained, essentially.
Yeah, but you also can't rob him completely, because the more discharge gas you take, the more to add to the suction, the less load you have to push liquid out. Yeah, so the more you're gonna have to hold back on the gas or the condenser. Keep saying gas cooler. The more you're gonna have to hold back on the condenser, and the more liquid it's gonna take to keep everything running, and you may lose load. We should have stopped calling them gas coolers. I'm tired of it. It's called condensers.
You know how many times? So it's bad. So like I do so much CO2 training, and then all of a sudden, like I did commercial refrigeration, and I was like, I caught myself like 5 different times. I'm like, it's condenser.
I'm so tired. I'm so tired of being corrected by engineers. Well, it's a gas cooler. Okay. Yeah, and you designed it wrong.
I hate you so much. Jesus Christ.
great. You know what to call it, but you don't know how to make it work.
No, we're just going to make it set the size of a tractor trailer. We're going to get 65-degree gas cooler outlet temperature to work perfect.
Yeah.
Actually.
Except when it gets to 10 degrees outside and the rack won't run.
Whatever.
When there's a slight breeze.
So, such an asshole. So, I can't even continue. Minimum allowable evaporator temperature to reduce the loads. What you're allowed. So for Kevin's case, probably about 26 or whatever. So you see that if you're running anywhere from a 40, I don't know what you do. That's so damn loud whenever you do that.
I hit the microphone with my knee.
Jesus. All right. Yeah. So 40 through 115, you would need an L2, depending on what gas you're using, or an L1. But these are the different things that need to be in consideration. I had someone that called me the other day. They were working on a unit and they were like, I got really high superheat going back to the compressor. And what had happened was the coil was iced up. So what did someone try to do? They tried to run in the hot gas to raise the pressure, even though they didn't even go look at the damn coil. And because they did that, it didn't have enough liquid for how much hot gas was there. Like the hot gas valve was bigger essentially than what the valve was. So first off, coil was iced up. Second off, they tried to raise the saturation way higher than what it was designed. So it was a freezer, it was supposed to be running at -10, and they had the thing jammed in at -14. So it would have never maintained anything but -4. But they just tried to overcompensate by just injecting a whole bunch. So the suction line going back was super, super hot. So I didn't know if it was a sizing issue or if it was someone just tried to hide something by doing that. But just keep that in consideration when you are doing these. It's sized off of, like, you see suction gas superheat. And it's telling you if you get all the way up to a 45-degree superheat, you might need to increase the power head up to a L2. Yeah. And unfortunately, I don't think this is the only document. So this is the Parker Sporlin 90-40. So this covers all kinds of the hot gas type stuff, but it also covers all the expansion valve power heads for that. And unfortunately, if you look at most of the Sporlin documents, they only cover the regular conventional power heads. They don't give you the L1 or L2, any kind of information. So if you go to look for it, you have to look at the desuperheating discharge hot gas bypass document, which is that 90-40 that I'm showing you right now on the screen.
Yeah. Just put the biggest one in. Just kidding. You got to look at the flow and what you're going to need. It seems every time I do one, I'm always, damn it, I should have put a bigger one in.
Yeah, because you want it to be nice and frosty.
Yeah.
But you also have to take in consideration
the hot gas valve.
Oh.
It's always a guessing game of how much you're actually going to need.
You never use this document?
I do, but you never know how much load you're going to lose.
What I would do is, and I know I'm just a computer jockey at this point, but what I would do is I would basically take the capacity of what the compressor is and how it's running and versus how it's going to be running in the wintertime, and then find out how much oversized it is. And if you can find out how much oversized it is at that point when it's super, super cold out, then you can figure out how much gas
at that
capacity.
Point, the hot gas doesn't work with a shit anyway because it's all getting stolen for the headmaster.
Oh my God, I hate you.
You don't work in the cold anymore. You don't.
I was in a freezer the other day with a sweatshirt because I didn't bring a winter jacket.
God damn it.
For the love of Christ. Kids.
It's only 4:00, so everybody's blowing my phone up.
Kevin's working 24 hours, so
Yeah.
Kevin's tech support line. Yeah. So then they also give you on this document, they actually give you the capacities for the liquid line solenoid that you would need, and also the hot gas solenoid size that you would need as well. Because like I said, you want shutdowns for both. Like I said, you can do this way, which is the most common, where you're injecting it directly into the ass end of the suction or right before the accumulator. It is a possibility to inject. They'll have an auxiliary side port on here, and they'll inject here. So the thought is that you don't need the desuperheating at that time, because at that point, the expansion valve will sense that the suction line is getting warmer, So naturally, it's just going to want to press down on that top of the power head and open up the valve more.
Yeah, no, that's the right way to do it, but that's the HVAC way to do it, and nobody's paying for all these ASCs.
If they would size it properly and maybe spend a couple more pennies on getting a digital compressor.
Racks. It all should be on racks. They shouldn't be on the roof. Anything on the roof is junk. Bring back mechanical rooms.
Yeah, I don't know. We know why.
Yeah, it's all about merchandisers and taxes and otherwise.
Wait, because the structural engineer has to figure out, well, that rack house is going to weigh X amount, and then you're going to need other leak detectors and exhaust fans and blah, 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 blah.
Yeah, until somebody dies on the roof from a lightning strike.
That never happens. Has that ever happened?
I'm sure it's happened. Live Florida, that shit just sneaks up on you.
That was years ago. Pat Tibbetts was down in Oklahoma, and they saw a tornado coming, and they were doing some roof work, I think down in up in Norman, Oklahoma or some shit. And him and whoever was working with him, I think it might have been Redneck Brett. I don't know if it was, I don't remember if it was him or maybe it was Jacob. I don't know. I don't remember. Someone was telling me the story where they were both on the roof and they took cover, duck and run in the damn downstairs in the building because there was a tornado just a heaving.
You say some of the gayest things sometimes.
What are you talking about? What'd I say? What'd I say? Heaving. Not heaping.
Fucking Connecticut people.
I'm not even from Connecticut. I'm from Pennsylvania.
Same thing.
You're such an asshole.
On that note, we're going to end it, and I'm going to go to sleep.
All right. Maybe you actually get some sleep this time. Talk to you guys later.